Hello and welcome back. In this video we will be looking at the next rule for taking derivatives, and that is the chain rule. So we should first review some of the earlier rules that we saw. We have the power rule. It says that when we take the derivative of x to the nth power, we're just going to get n times x to the 1 fewer power, x to the n minus 1 power. The sum difference rule, if we are adding functions or subtracting functions, the derivative plays really nicely, and we just take the derivative of both ones individually. We get f prime plus or minus g prime. And I'll use f and g prime to mean the derivative here. So the product rule, if we take the derivative of two functions that are being multiplied together, we've got to be a little bit careful. And the way that the product rule works is we'll take one function times the derivative of the other, and we'll add the other function times the derivative of the first. So we have, we'll end up taking the derivative of f and g individually and multiplying them by f and g respectively, or individually as well. So the product rule isn't too bad. And then we've got the quotient rule. The quotient rule is maybe the hardest one to remember, but it is worth memorizing. The quotient rule, I like to start with the bottom. So the derivative of a function divided by another function. The function on the bottom gets squared. And then on the top, we start from the bottom, and we go g of x times the derivative of the top minus the top times the derivative of the bottom. And again, the order here matters. If we put these in the wrong spot, because we're subtracting them, the order of the top matters. So these are four of the rules that we saw. Another one is that if there's a constant, we can pull a constant out of a derivative. And the chain rule that we'll learn is going to be looking at compositions of functions. So plugging two functions together. So if we have two functions g and f, we saw before that we can add them together, we can multiply them, we can divide them. The other thing that we can do is we can stick them inside one another. So if we have two functions g and f, I can take x and I can plug it into f, and whatever I get, whatever number I get, I can plug that back into g. And this is the composition of g and f. So let's do a couple of examples. Again, the order is going to matter here. So g composed with f, this is going to be, I like to think of it, x is closest to f, so we're going to plug x into f first, and then it's farthest away from g, so we'll plug that into g. So g here, I'm going to take whatever f of x is, and I'm going to plug it in. So this was f of x up here, so I'm plugging that in. And then g is just going to be whatever I plug in squared. So this is going to be 3x plus 1 quantity squared. And that is the composition here. But if I take f composed with g, here I'm going to plug x into g first, and then into f. Notice that the order f, g, x, f, g, x stays the same. So again, I'm going to plug everything into g first, so this is going to be the x squared. And then when I plug something into f, where does it go? Well, we multiply it by 3 and add 1. So we're going to take this, we're going to multiply it by 3, and add 1. And that is composition. What you'll notice is that these two are not going to be equal to one another. If I plug a 1 in, for instance, 3 times 1 is 3, plus 1 is 4, squared is 16. Whereas if I plug a 1 in here, I'll get 3 times 1 squared. Well, that's just 3, plus 1 is 4. And 16 is certainly not equal to 4. So these guys are not equal to one another, so you have to be careful which order are we doing the composition in. Is it g composed with f, or is it f composed with g? And now we get to the chain rule. And the chain rule is a little bit weird. If we have g composed with f, what we're going to do is we're going to take the derivative of g, and we're going to shove f back into G. So again, one way to write G composed with f. This is G of f of x. So what you'll notice is that here I'm taking f and I'm composing it with G prime, the derivative, and we can't forget to multiply by the derivative of f at the end. So this is our chain rule. It's a little bit weird. We have the composition that we're taking the derivative of, and the derivative is going to have another composition in it, plus this extra bit hanging out the back. So let's try that with this guy here. So what you'll notice is that if we want to take the derivative of G composed with f of x, we need to know the derivative of G and the derivative of f. So let's do that over here to the side. So if G of x is x squared, the derivative, using the power rule, I'll bring the 2 down, and it's just going to be 2 times x. So the derivative of G is pretty simple. And the derivative of f here, well, the derivative of 3x is just going to be 3. And the derivative of 1, well, that's a constant function, so that's going to be 0. So here are 2 of our ingredients to go into our chain rule. So this derivative is again going to be the derivative of G with f of x plugged in times the derivative of f. But we know all of these guys. So the derivative of G is going to be 2x. But I'm not plugging in an x, am I? I'm plugging in f of x. And then we're going to take everything times the derivative of f. So again, here is f of x, and I've plugged that in. The derivative of G is just going to be 2 times whatever we plug in. 2 times, so if we plug in x, it's 2x. If we plug in 3x plus 1, it's 2 times 3x plus 1. And then out the back, we have the derivative of f again. And then this is something that we can simplify. So this is going to be 2 times 3 is 6, times 3x, that's going to be 18x plus 1. And if we were to come up here and see, oh, here's our g of x, we could expand this if we wanted to. It's not that difficult to take 3x plus 1 and take it times 3x plus 1, and we should be able to get the same thing. Let's do the same thing for f composed with g. So now since the letters are mixed up, again, let's think about this carefully. We're going to take the outside function, and we're going to take its derivative, and we're going to plug in the inside function, and we're going to take it times the derivative of the inside function. So we know that f of x is just 3. So if I plug g of x in, so let's see here, g of x was x squared. So if I plug x squared into 3, I still get 3, right? This is a constant function. It doesn't matter what x is, I always just get 3. So that makes this first part really simple. The derivative of f with g plugged into it is just 3. Okay, so that's pretty straightforward. And we're going to take this times the derivative of g of x, which was this guy. So that's going to be 2x. And that is, again, really simple to simplify. That's just going to be 6x. This one right here, when we initially found f composed with g, we found that it was 3x squared plus 1. And if we take the derivative of this, the derivative of the 1 is just 0, so that goes away. The derivative of 3 times x squared is 3 times 2x. And 3 times 2x is 6x. So everything makes sense. Everything is working. The chain rule, surprisingly, works. So let's do another one. Here, I've got the square root of x squared plus x. And it's not obvious necessarily what it is that we're going to do. But what I can see is that, well, I've got this sort of outside function here being just the square root of whatever I've plugged into it. And then the inside function looks like x squared plus x. So what I can think is that, oh, I've got my function g of x, which is just the square root. Just take the square root of whatever we plug in. And then on the inside here, I have an x squared plus an x. So I can take the derivative of this guy by using my chain rule. This here is just g composed with f. If I plug f into g, I get this. So to do this, let's take a couple of derivatives. What is the derivative of g of x? So this square root, again, is just going to be x to the 1/2. So I pull that down, and then we'll get x to the negative 1/2, which just means I'll end up with a square root of x on the bottom. This is just a really nice derivative to remember how to do. But you can always do this with more steps as well. And then if f of x is going to be x squared plus x, the derivative, again, we'll just take the derivative of each part. The derivative of x squared is 2x, and the derivative of x is 1. So when we're doing this, we take the derivative of the outside function, which is this guy. And I'm going to write this down incorrectly for now, and then I'll fix it. So we take the derivative of the outside guy, but we plug in f of x. So this is going to actually be the square root of x squared plus x. So again, this is the derivative of g with f of x plugged into it. And then we're going to take this times the derivative of f. And what we get is going to be 2x plus 1 over 2 times the square root of x squared plus x. And that is all there really is to the chain rule, and a lot of it just comes down to identifying when we see a function in another function. So here it was clear that I'm taking the square root of a big mess on the inside. Well, taking the square root of something, that's just like plugging a function into the square root function. So we can get that. And I'll do some more examples in the next video.